Okay. So, now we are discussing about the reciprocal transducer, okay, in the last class. So, can you give an example of some reciprocal transducer? I said in reciprocal transducer TEM and TME must be equal to T and it will be real. So, in that case the example is crystal, ceramic, electrostatic transducer, all are reciprocal transducer. We will discuss how it is made, and then so those transducer are called reciprocal transducer. Okay. Then there is another kind of transducer which is called anti-reciprocal transducer. So, transduction factor is either real or complex, it may be either real or complex, but in case of reciprocal transducer TEM is equal to TME is equal to T, it is real and real consonant, real part, and both are equal. But in case of anti-reciprocal transducer, let us TEM is equal to minus TME. Okay, and equal to, let us, this is nothing but a phi m. Okay. In that case, what is V? V is equal to JdV into I plus phi m into U. Okay. Similarly, force is equal to ZMO into U plus minus phi m into I, or I can write this is minus phi m I. Okay, minus phi m I. Okay. So, this is the equation. So, in that case what is happening, this is okay, V is equal to JdV into phi m U, but this is nothing but a minus phi m into I. So, minus phi m into I is a, can I do that things? Can I realize it? No. So, and there is another relationship. What is ZMS? ZMS is nothing but a ZMO. So, since it is T is negative, so it will be positive. So, phi m square by ZdV. If T is equal to minus TME, so it will be positive instead of 1 minus Kc square. Okay. So, ZMS is equal to phi m square by ZdV. So, this is the relationship between the ZMS and ZdV, ZMS and ZMO, and this is the two equation, canonical equation. This is called canonical equation. Okay. Now, how do you realize it? How do you explain it? Minus phi m into I. So, we said I have two port network, this side is an electrical, applied voltage V, current I. This side is mechanical, applied voltage force U, and velocity is, mechanical velocity is U, force F, mechanical velocity is U. There is a principle called mechanical duality. Instead of that, can I do like this? Instead of force, I can change it U and I can say the F is here. Okay. So, source is current source, I can say it is a current source. So, if I have a resistance R and if I apply the voltage V, let us voltage V, then I say current I is flowing, I say V is equal to I into R. Okay. Now, can I say I can say also I equal to V by R, or I can say let us R y into V, where Y is called, R is called mechanical impedance, mechanical resistance, or mechanical, if it is complex then it is mechanical impedance. If I write a mechanical impedance, then I can put a box, let us, this is mechanical impedance is Z, this is the load Z. So, it is 1 by Z, once it is 1 by Z, then it is represented by a y, y into V, where y is called admittance, y is called electrical admittance. Similarly, if I say ZMO is mechanical, ZMS is mechanical impedance 1 by ZMS, I can say it is nothing but a YMS, which is short circuit mechanical admittance. Similarly, I can write ZMO, or I can write 1 by ZMO is equal to YMO, which is open circuit mechanical admittance, and I change the notation F to U and U to F. Now, it will come in mechanical admittance. So, then what will be the equation? V is equal to block electrical impedance into I. Now, if I said mechanical duality, then V will be, instead of ZEB, ZEF into I plus phi m into YMO F. Why? Because F is changed, so F is equal to nothing but a ZMO into U. I applied the mechanical duality, so U is nothing but a F by ZMO. So, F by ZMO is nothing but a YMO into F. So, YMO into F. Okay. Now, here F is equal to, here we know F. So, U is equal to phi m by ZMO. So, it is YMO into I, phi m YMO into I plus YMO into F, where YMO is nothing but a 1 by ZMO. So, the mechanical, so equation 1 and equation 2. Now, can I draw the equivalent circuit for anti-reciprocal transducer? Same thing. Can I draw the equivalent circuit for anti-reciprocal transducer? So, this is the equation number 1, V ZEF into I plus phi MO YMO F, and this is the equation. So, now I can say, I have applied a V voltage here, okay, and this should be passed through a impedance which is called ZEF, and current is I, okay, and then that should be passed through a, there is another impedance which is common, is phi m YMO, admittance is common, phi m into YMO is a common admittance, and since it creates an extra load for I have to put another impedance here which is nothing but a minus phi m YMO. Okay. Now, in this side I have an electrical mechanical U, okay, mechanical U, and admittance is YMO. I connect YMO this way, okay. So, YMO F, and then I have to connect another minus phi m, another load is here which is nothing but a minus phi m YMO. Now, if you derive, V is equal to ZEF into I plus minus phi m YMO into I plus phi m YMO into I plus phi m YMO F. F is flowing. F is flowing. F is flowing. Now, if it is that, then I can say this cancel, this supports the canonical equation. Then F is equal to, or U is equal to YMO into F. YMO into F. Sorry, this will be not connected here. This will be connected here. This is YMO. So, F is flowing. So, YMO into F plus minus phi m YMO into F plus phi m YMO into F plus phi m YMO I. This cancel. So, YMO F plus phi m YMO I. Support the canonical equation. So, my equivalent circuit is okay. Okay. Once the equivalent circuit is okay, now can I replace this minus phi m YMO? I want to replace this minus phi m YMO. Similarly, as in case of reciprocal transducer, what I do? I take a transformer. So, here also I can take a transformer. Okay. This is phi m is to 1. That time I taken 1 is to phi. Here phi m is to 1. So, if I apply a voltage V here, V voltage in here, and if I say I put an electrical impedance ZDB, then the current I is produced, then this side it will be phi m into I. Okay. Now, if I say mechanical side, I apply a U as a voltage. So, this will be phi m into U, phi m into U, and I said YMO, this is YMO, F is flowing. So, U, F is flowing, U is equal to YMO into F plus phi m I will be there, phi m I will be there, phi m I into YMO, which is the canonical equation YMO. Similarly, here if I say that V is equal to ZDB into I plus phi m into U. Now, again like a reciprocal, put the V is equal to ZDB into I plus phi m into YMO F plus phi m YMO I. Now, if I simplify this thing, you will come ZEF into I plus phi m YMO F. Reciprocal equation will come. So, I can draw easily the equivalent electrical circuits of that. So, in case of reciprocal transducer, electrical side is parallel to the transformer. Here YMO is parallel to the transformer, and it is admittance. Instead of impedance, I said it is admittance. So, this is called anti-reciprocal transducer. So, those theory will be used in construction of transducer. Let us start. What I said, can you give an example of anti-reciprocal transducer? Examples are electrodynamic transducer. All electrodynamic transducer are anti-reciprocal transducer. Okay. Let us start with a reciprocal transducer construction. Okay. So, what is the reciprocal transducer construction? In case of reciprocal transducer, I said an capacitance electrostatics transducer is a reciprocal transducer. So, I can say, I can draw that electrostatics transducer first. Let us I draw the electrostatics transducer. So, there will be a wire, there will be a casing. On the casing, I have a casing like this, freehand drawing. So, let us bear with me that it will not that good that you can draw, not that good. So, let us okay. So, this is the casing and here my diaphragm is connected. Okay. So, in between there is a plate and plate attach the diaphragm, and I have an isolation here, electrical isolation here, and I have another plate. Okay. So, I have another plate. Let us draw it clearly so that it can matches. So, let us, it is here and it is connected to here, and it is up to here and it is connected up to here. So, two plates are parallel, and one wire is touches this plate, and this is the another ground, shield ground, and another wire touches this plate. So, in this between these two plates, I apply a fixed voltage bias voltage V. So, if I apply a V0 voltage in here, then the capacitor, this is the capacitance, this distance is let us x0 and capacitance is C0. Okay. So, I cannot apply, then I have to connect and signal, alternative signal on top of that. So, let us draw the equivalent circuits instead of this circuits. So, what I do, I put a capacitance and then I say this is my variable capacitance, this is the C, this transducer is this one. Okay. So, this is variable capacitance C, and this capacitance is initially charged by putting a voltage V0. Okay. And capacitance value is C0, which is variable, and this is a CB and this is RB. So, what I draw that there is an options that okay, this can be connected, this voltage is supplied to there by a resistance, and this can be connected, this voltage is V is applied here. In between there will be a capacitance by which a source is connected, alternative voltage source is connected here. Okay. So, I apply there is a AC voltage when I apply the signal voltage I will be apply here. Okay. So, signal voltage I can draw like this, okay, and V0 is the static voltage. So, let us describe the functionality. So, initially there is no signal voltage. So, V0 voltage is applied and the capacitor is charged to C0, and the gap is, so at the voltage V0 the capacitance of this capacitor is C0 and the resistance RB is charged the capacitors. So, the value of RB should be very high, so that none of the AC current, the alternative signal which I will supply to the capacitor will pass in this side, this battery side. So, this RB should be very high, so that none of that your signal voltage should pass this RB and goes to the battery side loss. So, it is reduce the losses. And why CB is there? There is a source. So, this source will be not affected by this DC voltage. So, DC voltage will be blocked by this Cb capacitance. So, Cb should be very high compared to C0. Okay. So, the electrical side I can neglect the effect of Cb and Rb. So, Rb and Cb are required. Cb block the DC shift to enter in the applied signal, and Rb resist the signal should lost on other side. Okay. Now, if I apply a V0 voltage, then C0 will be charged. Once C0 is charged, the difference between the two plates is x0. So, I can write C0 is nothing but a epsilon, or not epsilon, I am not write correctly. So, epsilon S divided by x0. Epsilon is the dielectric constant, S is the surface area of the plate, and x0 is the distance between the two plates, that is the capacitance. And the charge on the capacitor Q0 is nothing but a C0 into voltage V0. Charge on the capacitor C0 into V0. So, if it is Q0 is equal to C0 into V0, and C0 is equal to epsilon into S. Now, I apply a V voltage of signal, variable signal V on this terminal. So, total voltage is nothing but a V plus V0 is equal to, the charge will be changed from Q0 to, let us for the applying voltage V, the charge is changed from Q0 to Q. So, Q plus Q0, Q amount of charge is induced here, extra charge. So, Q plus Q0 into, so displacement, if the charge is increased, displacement will reduce, or charge is decreased, displacement will expand. So, displacement is changed from x0 to x amount divided by epsilon into S, because capacitance is nothing but a dielectric constant into, so Q is, V is nothing but a Q by C. So, it is V is nothing but a Q by C. So, if it is V0, then V0 is nothing but a Q0 by C0 is nothing but a Q0 by epsilon S into x0. So, that is why I put the x in upper side and epsilon S is lower side. Now, if I simplify this, so V plus V0 is nothing but a Qx by epsilon S plus Qx0 by epsilon S plus Q0 x epsilon S plus x0 Q0 divided by epsilon S. Okay. Now, see that x0 Q0 and epsilon S is nothing but a, so it is nothing but a Qx by epsilon S plus Qx0 by epsilon S plus Q0 x by epsilon S plus V0. X0 Q0 by epsilon S is nothing but a V0. So, V0 is cancelled. So, variable voltage V is nothing but this 3 term. Now, this voltage is the AC varying voltage. So, that voltage induced charge is Q. So, Q is much less than Q0, and I say x is also much less than x0. The change of displacement and change of the charge is very less. In that case, this term I can ignore. So, I can say V is nothing but a Q into x0 by epsilon S plus Q0 into x by epsilon S. Okay. Now, if you say what is Q? Q is the charge. Charge is nothing but a, what is the relationship between Q and I? I is nothing but a dq by dt, first order derivative of dq by dt. So, if the V is varies in a complex manner, So, V is varying in a complex manner, let us V is varying in term of e to the power jx, j omega x or j omega, then I can say I is nothing but a j omega q. So, d by dt derivative is nothing but a j omega q, and or q is equal to I by j omega. Similarly, I can write what is u, x and u, relation between the x and u. So, u velocity is nothing but a dx by dt. So, u is nothing but a j omega x. So, x is nothing but a u by j omega. Now, I put this in this equation. So, what it will be done? x0 is constant, epsilon is constant, s is constant, I cannot change. So, q, I replace q by I. So, it is nothing but a I by j omega into x0 by, sorry, I should write straight. V is nothing but a I by j omega into x0 by epsilon s plus what is x? Is nothing but a u by j omega. So, I can write u by j omega into q0 by epsilon s. Okay. Now, what is x0 by epsilon s? So, it is nothing but a c0, 1 by c0. So, I can write V is nothing but a I by j omega c0, where c0 is equal to sigma epsilon s by x0, okay, plus q0 by epsilon s is nothing but a v0. So, I can write v0 by x0, v0 by x0 into u by j omega. Why I write v0 by x0? q0 by epsilon s. What is v0? v0 is nothing but a q0 by c0. So, it is nothing but a q0 by epsilon s by x0. So, I can write q0 x0 by epsilon s is nothing but a v0. So, I only have q0 epsilon s. So, I have to multiply divided by x0. So, I do the x0. Okay. Now, if you see, this is the canonical equation of a reciprocal transducer 1. So, what is ZEB? ZEB is nothing but a 1 by j omega c0. And what is phi? What is phi? Phi is nothing but a v0 by j omega x0. ZDB, so V is nothing but a ZDB into I plus phi into ZDB into U, or I can write not phi, it is a TEM, sorry, TEM, not phi. Okay, I write TEM. Okay, so this is canonical equation 1. Okay, now I derive the second equation. So, here what I said, if I apply a voltage, then a Q additional Q charge will be deposited, and that is why the capacitance plate will be displaced by X amount, and that create displace X amount, and to create the mechanical oscillation. So, electrical to mechanical I said. Similarly, if I apply a mechanical force on the plate, it should create an induced voltage V. So, if I apply a mechanical force, the electrical voltage will resist that force to change it. Okay. So, I can say the electrical voltage will resist. So, what is that force? Force F is nothing but a minus Q into Q0 divided by epsilon into S. So, the force acting on the diaphragm. So, this mechanical force want to change the diaphragm, and this amount, if the q amount of charge is due to the mechanical force is induced here, the charge will be changed. If the q amount of charge required to resist that force, then I can say F is equal to that the force produced by the q amount of charge, and it is negative because mechanical force is in this direction and electrical force is it. So, it is a opposite direction, or I can write F is equal to q0 by epsilon s. So, explanation is that if I apply a mechanical force on the diaphragm, the electrical energy try to reduce that force or oppose that force. So, as per the Newton's second law of motion, if I apply a force F, then if the electrical opposed force is same, then it will remain equilibrium. Okay. Let us that I apply a force F in this direction, then the electrical force will be produced this. Why this force will be produced? Because it induces some charges. So, that charges is the electrical force. So, since the two forces are in opposite direction, I can write in negative sign. Okay. So, if it is negative, then what I can do? I can write it is nothing but a, what is q0 by epsilon s is nothing but a minus q into v0 by x0, or I can write this is nothing but a, q is nothing but a y by j omega. So, v0 by x0 into I by j omega minus. Okay. So, total force acting on the plate is nothing but a force which is opposite that force. So, total force is nothing but a F plus F is equal to Z mu into U, particle velocity into impedance. When open circuit, electrical circuit, there is nothing is there. So, I can write F is equal to F minus F plus Z mu into U. What is F? Is nothing but a V0 I by x0 into j omega plus Z mu into, what is Z mu into U? Z mu into U. Now, what is this? T, if it is TEM, then it is nothing but a TME, mechanical to electrical, V0 by j omega x0. What it is here? It is TEM V0 by j omega x0. So, the TME is equal to TEM. So, it is a reciprocal transducer proved. Then, what is phi? So, T reciprocal transducer TME is equal to TEM equal to T is equal to V0 by j omega x0. Okay. Now, what is phi? Phi is equal to T by JdV. So, T is V0 by j omega x0 divided by what is JdV? JdV is nothing but a 1 by j omega C0, 1 by j omega C0. So, is equal to j omega cancel. So, it is nothing but a V0 C0 divided by V0 C0 divided by x0. Now, see, phi is V0 is real, C0 is real, x0 is real, and it is a constant. So, phi is a real constant. In case of reciprocal transducer, we have proved that phi is nothing but a real constant. Okay. So, phi is there. Now, can I do what is the relation between the ZMO and ZMS? So, by construction, what is ZMS of this transducer? Short circuit mechanical impedance. So, short circuit mechanical impedance means nothing is there, no voltage is there, no voltage is applied. electrical circuit is short, then it is nothing but a spring mass system. So, I can say this is nothing but a R m plus j omega m minus S by omega. Spring mass system, because this is a diaphragm, has a stiffness and has a mass, and it is hosted on a mechanical resistance for hosting. So, mechanical resistance, stiffness and mass of the diaphragm, which is nothing but a ZMS. What is ZMO? ZMO is when the electrical voltage is applied, then as soon as that short circuit is open, that electrical voltage is applied. So, when it is ZMO, when it is open circuit, then ZMO is equal to, you know that, what is the relation? ZMS is equal to ZMO minus phi square ZdB. So, I can write ZMO is nothing but a ZMS plus phi square ZdB. If I write that, what is ZMS? Rm plus j omega m minus S by omega, okay, plus phi square ZdB. What is phi square? Phi square is nothing but a V0 C0 square by X0 square. So, I can write phi square, and what is ZdB? ZdB is, let us phi square, and ZdB is nothing but a 1 by j omega C0, 1 by j omega C0. If I add this, so this is nothing but a, I can say Rm plus j. So, it is not j omega C0. So, it will be change only the stiffness. So, I can say omega m minus S dashed by omega, where S dashed is nothing but a S plus phi square by C0, phi square by C0. So, if we say mathematics shows that as soon as I open that short circuit condition, then the stiffness of the diaphragm has changed to S dashed. So, as soon as I open that open that short circuit condition, the stiffness of the diaphragm will change to phi square by C0. So, equivalence now, if the C0 is a variable capacitance, C0 is a variable capacitance. So, if the C0 is changed, the stiffness of the diaphragm will be changed. So, if the capacitance is changed, then the voltage will be, the stiffness will be changed. Okay, phi square by C0. So, I can say the voltage change is equivalent to create a vibration equivalent to capacitance change. So, next class I will discuss about the coupling coefficient, how it is work in that case of applied voltage. Okay.